Today we're taking a look at section 7.6 on polynomials and factoring, and we begin with some vocabulary. A monomial is a single term. It's a number, a variable, or a product of a number and one or more variables. And I have a list of examples. 5x minus 3y and 18a to the 5th b would all be monomials. A polynomial is a term or a finite sum or difference of terms with only non-negative exponents on the variables. And so we're going to look at some different ones. Starting with number 1, it says consider 5x squared minus 9x plus 6. What type of polynomial is this? What is this type of polynomial called? And because it has three terms, three meaning let me get my pen working here. Like a tricycle that has three wheels, a trinomial has three terms. What is the degree of the polynomial? To determine the degree, we look at the degree of the individual terms. This one has degree 2. The 1 here is implied, so that one has degree 1. A constant term has degree 0. So we have 2, 1, and 0. That means the degree of our polynomial will be 2. The leading coefficient, we take the term with the highest degree, and it's the coefficient of that term. So in this case, it would be a 5. Okay, in number 2, we have another polynomial. This one has two terms. So like a bicycle that has two wheels, it's called a binomial. It has two terms. The degree of the polynomial, again, we want to look at the degrees of the individual terms. The x cubed would have degree 3, the 8 would have degree 0 because it is a constant term. So because the highest degree is 3, that would be it. We notice again the leading coefficient comes from the term with the highest degree. The 1 is implied, so we put 1 there. Now we're going to start performing operations on polynomials, and the first thing they have us do is add and subtract, and I'm just going to look at an example. We have 6m to the 4th minus 3m squared plus m minus a second polynomial, 2m cubed plus 5m squared plus 4m plus m squared minus m. So what we want to do first is we want to take care of distributing this negative. So I'm going to change the subtraction to addition and just change the signs of the terms inside that set of parentheses. Now we're ready to begin adding, and we want to start with the term that has the highest degree, 6m to the 4th, and as I scan across, that is the only term that has m to the 4th. Okay, now we want to go with m cubed would be next, and again that's the only term with m cubed. So we'll put that next. Now we need terms that have m squared. We have three terms with m squared, so we need to combine them. Negative 3 plus negative 2, we just add the coefficients, we get negative 5. Plus 1 would be negative 4 m squared. Okay, and now we'll go to the m's. I'll do that in green. We have three terms with m's, and so we want to combine m plus negative 4m would be negative 3m. Minus an m would be negative 5m. Okay, no, negative 3 plus negative 1 would be negative 4m. So the key is we can just add the like terms, except when we have a subtraction, we want to distribute that over the entire polynomial. Distribute the negative, change it to adding the opposite. Now, in multiplying our polynomials, we'll start with FOIL. This is when you're multiplying two binomials. And let's take x plus 3 times x minus 8. Okay, the F is for the first ones in each of the sets of parentheses. Then outside is negative 8x. Inside is positive 3x. And last is 3 times negative 8 would be negative 24. Then we want to combine the two in the middle because they are like terms. And we get our end result. So FOIL works when we're multiplying two binomials. Let's look if we are multiplying something that has a little bit larger trinomial instead of a binomial. Plus 2n minus 3k. Okay, it looks like I'm going to run out of space here, so one of the things you may find useful. Okay, it's not going to let me write over there on the side, so let's see if I can do it at the top of the. So I'm going to take m minus n plus k. One of the things you can do this horizontally, like I did the last one. Multiply m times each one, then 2n times each one, and then negative 3k times each one. Or you can line them up and do a vertical arrangement. And I'm going to do negative 3k times k would be negative 3k squared. Negative 3k times n would be positive 3k n. Negative 3k times m would be negative 3k m. All right, positive 2n times k would be positive 2k n. 2n times negative n would be negative 2n squared, and that doesn't match anything, so I'm going to create a new column. And 2n times n is going to be a positive 2mn. Okay, now I go to the m's, and let's do m times k, so that's positive km. M times n, negative n would be negative mn, and m times m would be m squared. Okay, I'm going to put my sum over here. We'll have an m squared. Then adding these, we get a positive mn minus 2n squared minus 2km plus 5kn minus 3k squared. So I'm just adding them in their columns. So we can see that was kind of a nasty one that we came up with there. So you can use a horizontal arrangement like we did with FOIL, or if you prefer a vertical arrangement. You choose whichever works for you. Okay, factoring out the greatest common factor. We'll start with an easy one. What we want to do is look first at the coefficients and see if there's a common, what the greatest common factor of those three would be. And we can see that a 2 would come out of all of those. Now let's extend it to the m's. What's lowest power of m, they all have m squared. So what do I need to multiply times 2m squared to get 8m to the fourth? I need a 4m squared. Plus, to get a 6, I'm thinking this times what would give me a 6? I need a 3m, and then I need a minus 6. I've already got the m's that I need. So we factored out the greatest common factor. And let's do one more of those, one that looks a little bit more complicated. 2 times a plus b plus 4m times a plus b. This time the greatest common factor is the a plus b, so I'm going to take that out. And then I write down what's left over on the outside, 2 plus 4m. So although it looked more complicated, it actually turned out to be pretty easy. And that's going to help us as we move into factoring with grouping. And we'll do this one, 16a squared plus 10ab minus 24ab minus 15b squared. Okay, in factoring by grouping, we're going to group this into two pairs, and we're going to factor out the greatest common factor for each pair. So as I look at the first pair, I can take out a 2 from the 16 and the 10, and an a from the a squared and b, and that leaves 8a plus 5b. As I look at the next two, I can take out a negative 3b, not an a, negative 3b, that leaves 8a plus 5b. Now we have the situation we had up above. We have a greatest common factor of 8a plus 5b, and then we write what's left over, what's on the outside, and there it is factored. Notice it's factored when we have it written as a product, and that's what we've done in each one of these cases. We've written it as a product. Okay, factoring a trinomial. We'll start with a trinomial that has a leading coefficient of 1. And you should have done all of this that I'm going over in your algebra classes, but I'm trying to review each type just to refresh your memory. Okay, so when the leading coefficient is 1, we can go straight to two sets of parentheses. And what we want is two numbers that multiply to give us negative 35 and add to give us 2. So as I think about the factors of negative 35, a positive 7 and a negative 5. Notice we want the 7 to be positive because positive 7 plus negative 5 would give us a negative 2. So there's our factored form. So those are fairly straightforward. But when the leading coefficient is something other than 1, and let me put that one over here, it does get a little bit more complicated. All right.